This glowing sphere represents the Sun, which has a diameter of 1.4 times 10 to the ninth meters. Pretty big. The Sun has a special relationship to another object that is only about 1.7 times 10 to the negative 17th meters in diameter. It's pretty small. The subatomic particle called the proton. How is the gigantic Sun related to the extremely tiny proton? Read on to find out. A proton is one of three main particles that make up the atom. The other two particles are the neutron and the electron. Protons are found in the nucleus of the atom. This is a tiny, dense region at the center of the atom. Protons have a positive electrical charge of +1 and a mass of 1 atomic mass unit, AMU, which is about 1.67 times 10 to the negative 27th kilograms. It's a really tiny mass. Together with neutrons, they make up virtually all the mass of an atom. Notice, I said really tiny mass, even though this looks like a large number. That little negative sign makes a big difference. So that's like saying this decimal place is like 27 spaces in this direction. So that's a decimal with a lot of exactly 26 zeros in front of it. It's a little number. This video you can watch, but I'm going to tell you it's a little more advanced than what we're going to go. It talks about quarks and neutrons and protons and some electron shells. So feel free to watch it. Again, it goes a little deeper than we are going to go in this course. So question, how do you think the Sun is related to protons? Answer, the Sun's tremendous energy is the result of proton interactions. The Sun, in it, as well as in other stars, protons from hydrogen atoms combine or fuse to form nuclei of helium atoms. Remember, nuclei is plural for nucleus. The fusion reaction releases a huge amount of energy and takes place in nature only at the extremely high temperatures of stars such as the Sun. Identical protons, different elements. All protons are identical. For example, hydrogen protons are exactly the same as protons of helium and all other elements, or pure substances. However, atoms of different elements have different numbers of protons. In fact, atoms of any given element have a unique number of protons that is different from the number of protons of all other elements. For example, a hydrogen atom has just one proton, whereas a helium atom has two protons. The number of protons in any atom determines the electrical charge of the nucleus. The nucleus also contains neutrons, but they are neutral in charge. The one proton in a hydrogen nucleus, for example, gives it a charge of +1, and the two protons of a helium nucleus give it a charge of +2. So in essence, every single element is defined by how many protons it has. Likewise, if you know how many protons an atom has, you know what kind of element it is. So protons are the essence, that is what determines the element. All right, so all protons look the same. The only thing that is really ultimately different between each of the elements is that they have different numbers of protons. So in summary, a proton, one of three main particles that make up the atom. It is found in the nucleus. There's a typo there. A proton is one of three main particles that make up the atom. It is found in the nucleus. It has an electrical charge of +1 and has a mass of 1 atomic mass unit, or 1 AMU. Atoms of any given element have a unique number of protons that is different from the numbers of protons of all other elements. It's like their social security number. Only one person has that particular number. All right?